Hey everybody, we are starting a new module today. This is actually seventh grade work, but as we have moved to eighth grade algebra readiness, we've combined some of the sixth and seventh grade work together to get more done during the school year so you're ready to go in eighth grade. We're going to go back to proportional relationships. So let's think about what it means to be proportional again. This is a ratio basically, right? We have all those different rules that we worked with proportional relationships. So think about the recipe. I have a recipe for cookies that is 1 cup of sugar, 2 cups of flour, 1 cup of chocolate chips. I can double my recipe by having 2 cups of sugar, 4 cups of flour, 2 cups of chocolate chips, and that's still a proportional relationship. Okay, all I did was multiply each one of the ingredients by 2. So if I can multiply or divide each one of the ingredients by the same number to get a new recipe, those are proportional recipes, and they'll give you the same cookies. Okay, so our central question today is that we're going to be, how do we test for proportional relationship between two quantities? So if I have two recipes, how can I make sure they're going to make the same thing? You know what I mean? They have to be proportional. They have to be even. Okay. The warm up right now is going to be bus travels 18 miles in 15 minutes. At the same rate, what will the bus travel in 50 minutes? Okay. So problem 2 is a copy machine averages 210 copies in 5 minutes. At the same rate, how many copies will it make in 12 minutes? So go ahead and write down your essential question. How do we test for proportional relationships between two quantities? And work on those warm-ups. When I do the answer video for getting started, I'll include the answers to the warm-up as well. So go ahead, pause, write those two things down, and we'll move on to the next portion of this lesson, which is the getting started. So it says, keep on mixing. The students in Mrs. Rath's art class created various quantities of bluish-green paints, using pints of yellow and blue paint. Okay. So, you basically have your 2 right here and your total number right here. So you've got a lot of different types of paints right here. How many different shades did you make? So let's define what a shade is. Anytime that I use 2 different amounts of a color, I get a different shade, unless they are proportional. So if I look at 1 yellow pint, or 1 pint of yellow and 2 pints of blue, it's going to be the same shade as 2 pints of yellow and 4 pints of blue, because all I'm doing is doubling the recipe. 2 pints of yellow and 3 pints of blue is going to give me a different color, though. So how many different colors do we have here? Okay, that's the first thing you're going to figure out. Okay, and then some shades are more yellow than others. What one has the most yellow? Explain your reasoning. Okay, and then you're going to plot out number of yellow points, number of blue points, and draw a line connecting each point to the origin. What do you notice? Okay, so you work on those 3. We'll come back, we'll do the answers and talk it out. Remember to focus on this chart. If I can double or triple or multiply both parts of the recipe by the same number to get a new one, it's the same shade. If it's not divisible or a multiple of each of the 2, then it will be a different shade. All right, good luck.